Okay, number 14, I've got a graph, so this must be a quantitative command of evidence. It's the only questions that have graphs. Let's read. It looks like it's going to be a complete the text type quantitative. Sometimes they're support weekends. This is going to be a complete the text. Researchers conducted trials on a certain prescription drug delivered in immediate release capsules and extended release capsules. In clinical trials of the prescription drug, subjects were interviewed at regular intervals about their feelings of wellness, which is inversely related to the symptoms the prescription drug is meant to relieve. After each interview, the subjects were assigned a symptom score. A high symptom score corresponds to high intensity of symptoms, and a low symptom score indicates low intensity symptoms. Okay, so the symptoms are bad. You're sick. Okay, so it's inversely related to wellness. Okay, so as symptoms go up, wellness should go down, and vice versa. As symptoms go down, you're feeling better. You're well, basically. Okay, so what's happening here? They take the two drugs, the extended release, your symptoms go down, takes longer than the immediate release. Immediate release, you feel better, your symptoms go down. Then they kind of flatten out at a bottom level, and eventually extended release catches up, and at some point they go back up as the medicine wears off. Okay, so it looks like they kind of start at the same place, they end at the same place. There's just kind of a phase difference here. Let's see the answers. So again, for these, we're always looking for, is it true or accurate according to the graph, and is it relevant to answering the question? So whereas both drugs reduced mean symptom scores, they both did, yep, the immediate release drug resulted in a greater improvement in feelings of wellness. Well, it actually went quicker, but I don't think it went any lower. So greater, there's not an overall different absolute change here between the drugs. So I don't think that's correct, right? It didn't say faster, which would be true. It said greater, which refers to absolute change, I think. B, the efficacy of the drug for both time-release methods was substantially the same by the following morning. Well, I don't know, does it say anything about when it was given in the morning? I mean, after about half a day or more, they're both, useful. They both work is what efficacy means, basically. But the same or following morning, I don't think that part is right. It doesn't say anything about that in the text or the chart. C, the immediate release drug produced a wider range of mean symptom scores than the extended release drug after the first 8-hour period. Okay, so so after 8 hours is from here, where the immediate release hits its bottom, and it goes all the way up to the top, whereas the extended release, it hasn't hit bottom yet. It does go down almost as low, not quite as high. So actually that might be true, right? The immediate release drug did have a wider range of mean symptom scores. I'll accept that. Wasn't hugely different, but okay. At least accurate. Is it answering the question? Is it relevant? Maybe. I mean, we're trying to complete a statement, so there's no claim to be relevant really to here. I think that's accurate. Okay, that might be the answer. D, mean wellness measures for the immediate release drug declined more rapidly than the extended. Okay, here we're talking about the rapidity of the decline, but it's not the wellness measure that declined. That's wrong. The wellness improved as the symptom scores declined. They're inverse to each other. So D is definitely wrong. C has to be the right answer here. Okay, 15. Which quote from the poem most effectively illustrates the claim? Okay, so we're a command of evidence, not the support weakens type, but a quote that supports our claim. So let's read. An Irish airman foresees his death is a 1919 poem by William Butler Yeats. In the poem, the narrator predicts his death and the frame of reference it provides to his life. And then we have a colon, so this is going to be an example of not merely predicting his death, but the second condition here is the frame of reference it provides to his life. So that's what I need to see in my answer. A, I know that I shall meet my fate somewhere among the clouds above. Those that I fight, I do not hate. Those that I guard, I do not love. Okay, definitely is prediction of death there. Is that showing a frame of reference that provides his life? Those that I fight, I do not hate. Those that I guard, I do not love. Is that? I'm not sure that's a frame of reference of his life. That's just like sort of an opinion about his enemy. Let's keep going. B, my country is Killarton cross, my countrymen Killarton's poor, not likely end could bring them loss or leave them happier than before. That says nothing really about his death, so that's not right and not a frame of reference of his life. C, I balanced all, brought all to mind, the years to come seemed waste of breath, a waste of breath the years behind, in balance with this life and this death. Okay, he's definitely, here he's definitely putting a frame of reference to his life, right? He's mentioning his death, and in balance with his life, he's bringing it all to mind, and the years come, he seemed a waste of breath. So it's almost like he didn't really do what he needed or wanted or should have done, is what he's saying. This is the answer. This is the one that gives a frame of reference to his life. Definitely not A by comparison. This is it. Let's check D. Nor law nor duty bade me fight, nor public men nor cheering crowds, a lonely impulse of delight. No, that says nothing about his death or a sort of review of his life. C is the answer. Okay, 16. We've got a chart. This is going to be another quantitative command of evidence. Which choice best describes data from the table to support Persaud's conclusion? So let's see what Persaud says. Some climate models for the western United States predict that while total annual precipitation may remain unchanged from the present level, precipitation will become concentrated into fewer but more intense rain and snow events. Okay. So overall, we might get the same amount of rain, but we're going to have fewer, more intense storms, right? University of Texas climate scientist Persaud and her colleagues simulated how the amount of water entering aquifers and the amount used for irrigation would change. Okay, I'm not sure why intense storms or fewer would. Okay, not sure what the relationship is, but I mean, that might be important for them for some reason. Persaud and her colleagues concluded that concentration of precipitation into fewer events would result in a higher number of dry days, triggering more irrigation. So, okay, the condition here is fewer events, more irrigation, but that this change in irrigation output is highly sensitive to the baseline concentration of precipitation that currently exists in an area. Okay, again, I don't know what a baseline concentration of precipitation is necessarily, but they're saying fewer storms, which I get leads to more irrigation, right? That seems pretty clear. So what's in our chart here? Simulated change in annual aquifer input and irrigation output if concentration increases as climate models predict. Okay, so what do we have? Somewhat concentrated precipitation, even that's our baseline. Okay, so don't know what the baseline is, but looks like I've got two sort of sets of baselines, somewhat and evenly distributed. And then our bars are entering aquifers, used in irrigation surface, used in irrigation groundwater. Not sure what the difference, but the claim here is there's more irrigation. So I think aquifers, the yellow doesn't matter. I think we're looking at the black and the blue, and its percentage change, there's more. Okay, so the climate models predict more. Both are positive, so that's meeting that. That's true. But this change in irrigation is highly sensitive to the baseline. So it's sensitive to the baseline. So it differs from the one set here on the left and the one set here on the right. And it does. It's up a little in the somewhat concentrated, and it's up a lot in the evenly distributed. So, okay, let's see if we find the right answer here. If baseline precipitation is somewhat concentrated, the amount of water being used for irrigation will increase 1% for surface water, 2% for groundwater. Okay, so somewhat concentrated, yeah, looks to be up 1 and 2, so that's accurate so far. Whereas the amount of water entering aquifers will increase 11%. Okay, that actually might be true. Aquifers go up 11% if it's evenly distributed. This is accurate, but it's not meeting the condition, right? Remember, our condition was there's more irrigation, so they're both positive, and we want a difference between the left and the right bars, which is irrigation on irrigation. We don't care about aquifers. It only says change in irrigation in the conditions. So that's not right. I think aquifers is sort of the unused legend item here, like the unused column in rows or tables. Okay, so B, if baseline precipitation is somewhat concentrated, the amount of water entering aquifers, again, we don't really care. It is, that's accurate. It's going up the yellow 5%, but I don't think we care about aquifers. Will increase 1%. That's, again, this is accurate. I just don't think it's relevant. Our answer says nothing about aquifers. C, if baseline precipitation is somewhat concentrated, water used for irrigation will increase only 1% for surface, 2%. Okay, so I think that was somewhat concentrated. Yeah, that was up. Black and the blue are up 1 and 2%. Whereas it will increase more substantially if baseline precipitation is evenly distributed. So evenly distributed is the set of bars on the right, and it's more. It doesn't say how much more, but it's definitely substantially more. So I think C is going to be our answer. D, if baseline precipitation is somewhat concentrated, water used for irrigation will decline by, no, irrigation does not decline. That's not accurate to the chart. C is going to be our answer. So this is a really tricky one in terms of understanding. I don't understand what the baseline concentration is, why we're looking at aquifers versus irrigation. Doesn't make sense to me, right? I kind of checked out after there are going to be fewer and more intense storms in understanding. But that doesn't matter. I can still take the conditions of the question prompt. More irrigation, I know we're looking for that, and that changes based on the baseline concentration of precipitation, which means it's different along the x-axis. So I can use that to answer the question.